Hi everyone. This activity is going to serve as a review and both your Unit 3 exam. So I am going to review each topic first, and then you will have a question to answer as part of your test. So the first topic is arithmetic sequences. So first, what is a sequence? A sequence is a series of numbers, or what we call terms, that can be predicted by some kind of pattern. Arithmetic sequences are patterns or sequence where you add or subtract the same value to get from one term to the next. So the following are examples of arithmetic sequences. So if we take a look at the first one, 2, 5, 8, 11, so on. In order to get from one term to the next, you need to add 3. So this is arithmetic because you're adding the same amount each time. In example 2, you are adding 2 to get from -3 to -1, from -1 to 1, and so on. So there's a pattern of adding 2 to get to the next term. In this case, we're going to from 6 to 1, from 1 to -4, and from -4 to -9. So in this case, we're actually subtracting. So we're subtracting 5 each time. So any sequence that involves adding the same number or subtracting the same number, similar to a linear function, would be arithmetic. Now you're going to answer which of the following sequences, 1, 2, 3, or 4, is arithmetic. Okay, next we're moving on to sequence notation. So here we have the following sequence: 1, 5, 9, 13, 17, 21. So each number in the sequence is labeled as either A1, A2, A3, and so on. This tells you the place of that value in the sequence. A1 means that's the first term. A2 is the second term of the sequence. A3 is the third term, and so on. So AN represents the nth term. N represents the term number. Okay, so the nth means any term number. Okay, it's just it's a generic term. D is the common difference between the terms. So going back previously, what we saw when we added or whatever we subtracted to get to the next value would be the common difference. So for example, looking at this same sequence, it says, what is the common difference, which is labeled as D? So it goes from 1 to 5, from 5 to 9, and from 9 to 13. So I know if I subtract one term from the other, 5 minus 1 would give me 4. So I know I'm adding 4 to get from one term to the next. So our common difference here is 4. What is the value of A7? So A7 means the 7th term. Okay, so if I were to continue this sequence, we have A6. In order to get A7, I would add 4 to 21. So that would give me 21 plus 4 is 25. Okay, that's the 7th number in the sequence, the 7th term. Next, they want A of 10. So you would have to keep going. A of 8, A9, and A10. So we have to keep adding 4. And it gets pretty, repetitive. So 25 plus 4 is 29. 29 plus 4 is 33. And 33 plus 4 is 37. Okay, so you would have to keep adding 4. There's an easier way to do this, and that's with the general formula for an arithmetic sequence. First, you're going to identify the common difference of the following sequence for question 2. So question 2 is, what is the common difference, D, of the arithmetic sequence 5, 8, 11, 14, and so on? Okay, like I said before, there's a way that we can write a rule so that we can figure out any term in a sequence. And that's this formula right here. AN, which is the nth term of the sequence, equals A1, which is the first term, plus D, which is the difference, common difference, and N is the position number, the term number you're trying to find. So this formula we can use to find any term of any sequence, okay? And I'm going to show you how that works in the next slide. So in this particular question, they want you to find the 35th term in the sequence 3, 9, 15, 21, so on. So first what we want to do is we want to write the general rule, okay? So this is exactly what the general rule is. AN equals A1 plus n minus 1 times D, or D times n minus 1. Either way it works. So the only things that you need to substitute for the general rule are A1 and the common difference D. So that means we're going to have AN equals to A1, which I'm going to keep blank, plus our common difference times n minus 1. So we just need these two things. So A1, again, if we look here, is our first term. Our first term of our sequence here is 3. So that is A1. So I'm going to substitute that right here. Our common difference. What are we adding to get to the next term? So we go from 3 to 9, from 9 to 15, and 15 to 21. So here I see that we're adding 6 each time. So our common difference is 6. So this is our general rule. Okay, you can use this rule to find any term of the sequence. If you wanted to find the 100th term, instead of adding 6 100 times, you can use this formula. Now, they ask us to find the 35th term. Now they give us a specific value for n. When they tell you the term number, you're going to substitute 35 for n, because that's the term number. So we're going to use our formula, and we're just, where we see n, we're going to substitute 35. So it's going to be a n, and here we have 35, plus 3, equals 3. Sorry about that. Equals 3 plus 6, parentheses, n minus 1, and we know our n is 35. That's our term number. Okay. And now all you need to do is just evaluate this using your order of operations. So A of 35, I'm bringing down. The first thing you need to do is your parentheses. 35 minus 1 is 34. Now at this point, what do we do? Do we do the addition or do we do the multiplication? Think of PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So I know that the multiplication is going to come first. So we're going to do 6 times 34, which is 204. And lastly, I just add. So the 35th term is 3 plus 204, which is 207. Okay. So if I kept going, if I kept adding 6, the 35th number in this sequence would be 207. Okay. Now, let's move on. Again, feel free to pause at any time. You can go back. Here's question 3. What is the nth term of the sequence -1, 3, 7, 11? Question 4. So using your formula from question 3, what is the 20th term of that same sequence? -1, 3, 7, 11. Okay, now we're moving on to system of equations. A system of equations is made up of 2 or more equations having the same variables. You know that every point on the graph of an equation in 2 variables represents an ordered pair that is a solution to the equation. So here you can see we have a graph with a system of equations represented on this graph. We have 2 linear equations, y equals 2x plus 2, and y equals x minus 1. And the solution is that intersection point, which I have labeled right here, -3, -4. So it's any ordered pair that satisfies all the equations in the system. So that point, -3, 4, satisfies both equations. It is on both of those lines. Okay. So now you're going to answer the next question. Question 5. What is the solution of the system of equations shown in the graph below? Okay. Next topic is solving a system using the substitution method. Okay. Here we have 2 equations. Y equals 5x minus 7, and the other is -3x minus 2y equals -12. This was the first way we learned how to solve a system of equations using an algebraic method. So substitution means to substitute an equivalent expression in for a variable in the other equation. So I have 5 steps for us to help us through this problem. So when you're solving an equation, system of equations using substitution, you want to, step 1, solve an equation for one variable. Pick the easier equation. The goal is to get y equals, x equals, a equals, etc. In this case, we already have that done for us. In the first equation, we have y equals, so y is isolated. We know y is equal to 5x minus 7. So step 2 is to substitute. We're going to put the equation from step 1 into the other equation. So since we know that y equals to 5x minus 7, we can substitute 5x minus 7 in for y in the other equation. So let's see what that looks like. So we have negative 3x minus 2, and I'm going to put that in parentheses. Equals negative 12. Now you can see we went from an equation with 2 variables to an equation with only 1 variable, so we can actually solve. Now step 3 is we're going to solve the equation, right? We want to get the variable by itself. So in this case, the first thing you want to do is you want to use your distributive property. When you see a number outside the parentheses, that should tell you, okay, I know I need to distribute first. And notice this is a negative 2, so be careful. We're going to take this negative 2 and distribute to both terms in the parentheses. We didn't touch this negative 3x, I'm bringing it down. Negative 2 times 5x is negative 10x. And negative 2 times negative 12 is positive 14, equals to negative 12. Now, this is just solving for x. We have like terms that we can combine first. Negative 3x minus 10 is negative 13x, plus 14 equals to negative 12. Now I'm going to subtract the 14 on both sides. We get negative 13x equals, now be careful, use your calculator if you need it. Negative 12 minus 14 is negative 26. Then you divide by negative 13 on both sides. Negative 26 divided by negative 13, x equals to positive 2. So now that we have our x value, you want to plug it back in to find the other variable. So substitute the value of the variable into the equation. So since I know x equals 2, I can choose either equation. So the top one is more simple than the bottom, so I'm going to choose the top. I know y equals 5x minus 7, and x equals to 2. So I have y equals to 5, parentheses 2, minus 7. X is 2, that we got from the first piece. Then you just simplify this. You do multiplication first. 5 times 2 is 10, minus 7, and we get y equals to 3. 10 minus 7 is 3. So the intersection point, the solution of both of these equations, is 2, 3. Okay. Now you're going to try one on your own. Solve the following system using the substitution method. You can go back, make sure you're using the steps, write this down, and try this on your own. Okay. Solving systems using the elimination method. Here we have 2 equations written right on top of each other, right? Both of these equations are in standard form, okay? That's when you want to use the elimination method. So both equations are in standard form. which is ax plus by equals to c. Your x and y's are on the same side, and by putting them right on top of each other, you are lining up the like terms. Okay, which I'm highlighting. So you want to think to yourself, which variable has the same coefficient? So the variable that has the same coefficient is x. X has this 4 and -4, and since they're opposite signs, different signs, you're going to add them together. Plus, plus, plus. We're adding all the like terms together. Once you choose addition or subtraction, you're following through with everything. So 4x plus -4x is 0. 8y plus 2y is 10y. And 20 plus -30. Use your calculator, that's -10. We don't need to keep that 0, so I'm just going to erase it. We eliminated the x. Now we could simply solve for y. So at this time, we're going to divide by 10 on both sides. -10 divided by 10 is -1. Now, this same step applies. Substitute the value into any of the other equations to solve for the other. So since we have y, which is -1, we need that x as well. So let's take the top equation. Here they're both pretty much the same in terms of steps. So we'll take the top and we'll substitute -1 for y, which I'll put in a different color. Okay, so I'll bring down this 4x. 8 times -1 is -8 equals to 20. I'm adding 8 on both sides, and -8, so the inverse is addition. We get 4x equals to 20 plus 8 is 28. Dividing by 4 on both sides, we get x equals to 7. So 7 -1 is the solution of those two equations. If we were to graph them, that is where they would intersect. Now you're going to try the following system of equations on your own. Okay, so you have 7x plus 2y equals 24, and 8x plus 2y equals to 30. Now you're going to do the same for question 8. If x plus y equals -10 and x minus y equals 2, what is the value of x? Okay. Now we're getting on to modeling systems of linear equations. So let's read the following problem. Lizzie has 30 coins that total $4.80. All of her coins are dimes, D, and quarters, Q. Which system of equations models this situation? So, as I'm reading this, I'm going to underline, I'm going to color code this, okay? So we know Lizzie has 30 total coins, right? And the cost of those coins is, total cost is $4.80. she has dimes, which are represented by D, and quarters represented by Q. Now, in this particular case, we're dealing with two different pieces here. We're dealing with the amount of coins she has and the amount of total money she has. So one equation is going to represent the total number of coins, and the other one's going to represent the total cost. So we know the total number of coins is 30. So one equation is going to equal to 30. So we know the number of dimes and the number of quarters that she has is going to equal 30 coins. So that means the number of dimes, which is represented by D, plus the number of quarters represented by Q is going to be 30. Okay, this represents the total amount of coins. So now we can go and we could kind of get rid of options of answers that do not have this equation. So I see that we can get rid of 4, because D plus Q is $4.80, and we can get rid of 1. Now, if you take a look at these other 2 and 3, which we have left, they have 0.10 and 0.25 as coefficients. Now, where did that come from? Well, we know that a dime is 10 cents, right? 0.10, and a quarter is 25 cents, 0.25. So we need to make sure that the 10 cents matches with the dimes and the 25 cents matches with the quarters. So that would mean it would be 0.10 cents times each dime plus 0.25 times each quarter would equal to 4.80. Okay, so which one would that be? So it's going to be 2. Okay, here you would have to use your own knowledge that a dime is 10 cents and a quarter is 25 cents. Okay, now it is time for you guys to try one on your own. So, the Celluloid Cinema sold 150 tickets to a movie. Some of these were child tickets and the rest were adult tickets. A child ticket cost $7.75 and an adult ticket cost $10.25. If the cinema sold $1,470 worth of tickets, which system of equations could be used to determine how many adult tickets A and how many child tickets C were sold? Lastly, system of equations word problems. So we're going to do one type of word problem, and you guys are going to do one that's very similar to this. Find the value of 2 numbers if their sum is 12 and their difference is 4. Okay. So let's highlight some important information here. So first, they want us to find the value of 2 numbers, right? That's our question. So let's write that down. That's our question, right? That's what we're trying to answer. Their sum is 12, and their difference is 4. Okay, so we got to break down what this means. So sum means when you add the two numbers together, sum is addition, right? When you add the two numbers together, number plus number, it gives you 12. Difference is subtraction, okay? So when you subtract those two numbers, number minus number, that gives us 4. So since we don't know what these two numbers are, we're going to label them as x and y. We're going to give them variables. So I know that x plus y is going to give us 12 if we add them together, and x minus y would be 4 if we subtracted them. So now that I see the two equations that we created, I notice they're both in standard form. So I think the best way to go about this would be to use elimination. So let's put them right on top of each other. So we have x plus y equals to 12, and x minus y equals to 4. Okay, I see that if I add these equations together, the like terms of positive y and negative y would eliminate. So I'm going to go ahead and add everything together. So x plus x is 2x, y plus negative y is 0, and 2 plus 4 is 16. Next, we're going to divide by 2, and we get x equals to 8. So I know my x value is 8. What is my y? So now I can simply just substitute that back into one of our formulas, into one of our equations. So I can use, if I use x plus y equals 12, I know x is 8. So that's going to be 8 plus y equals 12. And we subtract 8 on both sides. And we get y equals 2, 4. Okay, so let's see if these numbers work. If I add 8 and 4, is their sum 12? Yes, right? 8 plus 4 is 12, and 12 equals 12. Is their difference 4? 8 minus 4, does that equal to 4? And in fact, it does. So the two numbers we figured out were 8 and 4. Okay, so you're going to do a question very similar to this one. The difference of two numbers is 3. Their sum is 13. Find the numbers. And this is the last question of the test.